In the spring of 1618, Johannes Kepler was trying to prove the planets were singing. Not as a metaphor, literally. He thought he could work out the notes. He had been at it for 22 years. That spring, he found something. We call it Kepler's third law. Every planet around the sun obeys it. Every moon obeys the same relationship around its own planet. Every system we have found since obeys it with its own number. It sits in Book 5 of a book about music, not in an appendix, not as an afterthought, at the end of the chapter on harmony, because that is where it came from. And Kepler was not working alone. 2,000 years earlier, the Pythagoreans argued the cosmos was built on musical ratios. Kepler inherited that question. He named his sources. He said so in print. So this is not two civilizations arriving at the same idea by accident. It is one man picking up an ancient problem with better observations than anyone had ever had. And the strange part is what happened next. The argument was wrong. The search worked anyway. By the end, you will know exactly what he measured. You will know why those numbers are still correct today. You will know what he got wrong about them and who corrected it 69 years later. And you will know why the honest version is stranger than the myth. One thing first, because it matters. The planets do not make sound. Space does not carry it. There is nothing to hear. Kepler knew that. He was not claiming otherwise. What he found were real ratios, measured and silent. And nothing in this video says the ancients knew physics. They did not. What they had was a question. They asked it for 2,000 years. Nobody could answer it until Kepler measured. To understand what happened in 1618, you have to go back 22 years. In 1596, Kepler published his first book. He was 24. He thought he had found the blueprint God used to build the solar system. There were 6 known planets. 6 planets, 5 gaps. And there are exactly 5 regular convex solids in 3-dimensional geometry. The cube, the tetrahedron, the octahedron, the dodecahedron, and the icosahedron. 5. You cannot construct a 6th. Kepler nested them inside one another and claimed the gaps between them set the planetary orbits. It is a beautiful idea. You can still buy models of it. It did not fit the numbers. Kepler knew. He said so. He kept working. Then he inherited the best observations in the world. Tycho Brahe had spent decades measuring planetary positions by eye, before telescopes, from an island observatory. His readings were good to 1 or 2 minutes of arc. That is roughly a large coin, seen from 100 meters, among the most precise naked-eye observations ever made. When Brahe died, Kepler got them. Against that data, the beautiful idea failed again, but something else came out of it. In 1609, he published the first 2 laws. Planets move in ellipses, not circles, and they sweep equal areas in equal times, which means they speed up near the sunday. That second law is the one that matters here. A planet does not travel at a constant speed. Near the sun, it races. Far out, it crawls. Every planet has a fastest speed and a slowest speed. 2 numbers. For every planet. Kepler now had a table of them. And he already knew what he wanted to do with it. Because out of an ancient tradition had come a real result about strings. Take a string, pluck it, then half the vibrating length and pluck it again. The note jumps by an octave. The ratio is 2 to 1. Take 2/3 of the length. You get a 5th. Take 3/4. You get a 4th. Pause. Certain simple ratios give the strongest consonances. That is a real fact about vibrating strings. It is still true. You can test it this afternoon. Then they generalized. If number governs sound, they reasoned, number governs everything. The planets are spheres in motion. Motion produces sound. Therefore, the heavens make music. The observation was right. It was the extension that went wrong. The idea survived for centuries. Ptolemy wrote a book called Harmonics around the year 150, working out the mathematics of consonants. After him, scholars preserved the doctrine. They taught it and argued about it. But nobody tested those ratios against the sky with anything like the numbers Kepler would have. The music of the spheres was an argument, not a reading. Kepler had been working on his own version since 1599. He only got hold of Ptolemy's Greek text around 1607. It was sent to him by his friend and patron, Herwart von Hohenberg. So he did not simply inherit the answer. He built his own for 8 years and then found the ancient text had been there first. The historian Peter Pesic puts it exactly. Kepler reinvented this tradition and then rediscovered it. And by the time he took the problem up, the Pythagorean doctrine was already cracking. In 1581, a Florentine lute player published a book about music. His name was Vincenzo Galilei. Numbers do not decide what sounds good, he argued. The ear does. Go and listen. He tested it himself, later, by hanging weights from strings. To raise a string by an octave, you do not double the tension. You quadruple it. The clean 2-to-1 had a square root hiding inside it. Galilei had a son. The son was called Galileo. Now here is where the two halves of this story meet. In October 1617, Kepler set out on a journey. He was going to defend his mother. Katharina Kepler had been accused of witchcraft. The case would run for over 3 years. She was eventually imprisoned, chained, and shown the instruments of torture. Kepler ran her defense himself. She was released. She died the following spring. He took a book with him for the journey. Vincenzo Galilei's book, the one that broke the ratio. He recorded that he read it with the greatest pleasure. A few months later, he found the third law. And it was not a good winter. He had buried a daughter that September, Margaretha Regina. She was 2. On the 9th of February, he buried another. She was 6 months old. Her name was Katharina, after his mother. He put the astronomical tables aside. That work needed a steady mind. He went back to the harmony book instead. Here is what he actually measured. Not the size of the orbits, not the distances, angular speed seen from the Sunday. Picture standing on the sun, watching a planet crawl across the sky behind it. At its closest approach, it moves quickly. At its furthest, slowly. Kepler took the fastest angular speed of each planet and divided it by its slowest. One number per planet, a ratio. Then he compared each ratio to the musical intervals. Before the results, the obvious objection. This is numerology. Take enough numbers, allow enough slack, and everything looks like a ratio. The objection is half right, and it is worth saying why. It is right about the interpretation. It is wrong about the measurement. Kepler had fixed which ratios counted before he looked. Book 3 of the same work derives the consonances from geometry, and there are 7 of them. That makes the comparison more constrained than simply hunting through numbers for a match. And there is a harder test than any of that. A numerological pattern has no mechanism. Nothing explains why it should hold. A physical pattern has a cause, and the cause predicts things the pattern never did. Hold that. It decides everything later. Now the numbers. Every ratio here is the fastest speed over the slowest. Saturn, 5-4. In music, a major third. Jupiter, 6-5. A minor third. Mars, 3-2. A fifth. The Greeks called it the diapente, Venus, 25 to 24. Barely anything. That interval is called a diasis, and it is about the smallest step the ear can hear. Venus has one of the least eccentric orbits, so its speed hardly changes at all. Then Mercury, 12 to 5, an octave and a minor third, the widest of the six. Mercury has the most stretched orbit of any of them, so its speed swings hardest. He gave them voices, the way you would a choir. Mercury sang soprano, Venus and Earth were the altos, Mars was the tenor, Jupiter and Saturn, the basses. And Earth, 16 to 15, roughly a semitone in familiar Western music. From mi to fa. Kepler noticed something about those two syllables. He wrote that the Earth sings mi, fa, mi, and that you may infer from the syllables that in this our home, misery and famine hold sway. Mi, fa, mi, my Syria, fames. A Latin pun buried in the measured ratio of the orbit you are standing on. He wrote that in the winter he buried his daughter. 6 planets, 6 ratios, from real observations. Everyone lands on, or near, a musical interval. Then he tried something harder. Not each planet against itself, each planet is against its neighbor. The fastest speed of one against the slowest of the next. He called these the converging and diverging motions. Every adjacent pair came within a decis of a consonance. Every pair but one. The diverging motion of Mars and Jupiter gave him 18 to 19. That is not an interval. It is not close to one. It is the only deviation in the whole system, larger than the ear can ignore. He could have left it out. He published it, said he could not explain it, and moved on. Worth noticing about a man usually filed under mysticism. A modern scholar, D.P. Walker, put the difference exactly. The Greek and medieval music of the spheres was metaphorical. Kepler's harmonies are real and soundless. He was not hearing anything, neither was anyone else. He was measuring, and the measurements landed where 2,000 years of argument said they would. And then, at the end of that same book 5, he wrote down one more thing. Take any planet. Take the time it needs to go once around the sun, and square it. Take its average distance from the sun, what astronomers call the semi-major axis, and cube it. Divide one by the other. You get the same number for every planet. Every planet around the same star. Change the star and the number changes. The relationship does not. That is Kepler's third law. He very nearly threw it away. He had it on the 8th of March. Then he checked the arithmetic and found an error. He rejected the whole result as false. He came back to it on the 15th of May. That time it held 10 weeks between having the answer and being willing to believe it. It is not in an appendix. It is not a separate discovery. It is at the end of the harmony chapter, because the harmony search is what produced it. He had spent 22 years looking for a ratio that held across all the planets at once. He found one. It was not musical. It has survived every test since, within the physics it describes. It gives you the orbit of every moon, every distant satellite, and every one of the thousands of exoplanets found since 1992. 69 years later, Isaac Newton explained why. Gravity weakens with the square of the distance. The same law that pulls an apple down sets the acceleration holding a planet on its path. Newton showed they were one law. Work out what that does to an orbit and Kepler's ratio falls out of the mathematics. In the two-body case, it follows from the physics. And Newton could say what sets the number. It is the mass at the center. That is why every star gets its own. Which is the answer to the objection from earlier. The third law eventually got a physical explanation. The musical reading never did. Both observations were real. Only one acquired a physical cause. So what happened to the music? The ratios are still there. Kepler's Saturn still falls near a musical third. Earth still steps from mi to fa every year in silence. The speed ratios come from the geometry of the orbit. Calling those ratios music was Kepler's. He found something real and gave it the wrong explanation. That is a different kind of failure from finding nothing at all. There is one more thing in Book 5, and it is the part nobody quotes. Kepler turns on his own tradition. He goes after Ptolemy directly. The ancient harmonies, he says, are arbitrary analogies. They have no cause in physical motion. Then he goes after a living man. Robert Fludd was publishing enormous diagrams of cosmic harmony at exactly the same time. Kepler read them. He said they had symbolism and no mathematics. Read that again. The man we file under mysticism was the one attacking the mystics. He was not corrected by us. 400 years later, he did it himself in the same book against the most famous occultist of his own decade. And the standard he used is the one still in use. The Pythagoreans found the pattern. Galilei tested the string. Kepler kept measuring. Newton asked what was underneath. The difference between them was what each one did next, which is why this outlives Kepler. There is an enormous amount of material built on ratios found in nature, frequencies that heal, proportions in galaxies, ancient diagrams that supposedly encode the atom. Almost all of it stops where Fludd stopped. It finds a number and calls that an explanation. Kepler is the clearest example of why that is not enough. He found striking ratios in real astronomical data, and the ratios still were not the answer. In the spring of 1618, in Linz, a man was trying to prove the planets were singing. His original idea was wrong. For 22 years, he kept searching anyway. He had also just buried 2 children, and his mother was awaiting trial. He was more careful than anyone before him. He wrote his numbers down where we could check them. The planets do not sing, but the Earth really does move from mi to fa and back again once a year. Kepler measured it, and then he found the thing he was not looking for. Which leaves one question standing. How do you tell, from inside a pattern, whether there is anything underneath it? Kepler could not tell. It took Newton to settle it, and we are not obviously better at this than he was. Ancient wisdom, quantum mystery, direct knowing. This is quantum gnosis.